Hi Chem class, welcome to stoichiometry, or what I like to think of as putting moles to work. You've done some work so far with moles and you've done some work with chemical equations, and now it's time to put them together and see how moles can have practical applications in laboratory examples. What information are you going to need to be successful in this unit? First off, writing formulas and balanced chemical equations will be here with us to stay, folks. In addition to that, doing mole conversions and also dimensional analysis. This unit is all about dimensional analysis. If you can do dimensional analysis, you can do stoichiometry. Let's remember for a second what it means to have a balanced chemical equation. When we see a balanced chemical equation like this, we have to interpret what the numbers in the equation mean. And specifically here, we're looking at the coefficients. So remember, we can interpret this in two different ways. We can think of this as being 2 moles of carbon plus 1 mole of oxygen, yielding 2 moles of carbon monoxide. Or we can think of it as being 2 atoms of carbon plus 1 molecule of oxygen, yielding 2 molecules of carbon monoxide. One way we cannot think of this is if it were a mass ratio, right? This is not allowed. 2 grams of carbon plus 1 gram of oxygen will not give us 2 grams of carbon monoxide. Can't use masses when we're talking about coefficients. Coefficients refer to moles or particles. Now, there's 3 new terms that we're going to need in order to be successful in this unit. So I'm going to give you a minute now to define them on your own. Your textbook is a good place to do this. Google, of course, is great. Just make sure that you're using definitions that make sense for our context. For mole ratio, you should have come up with a definition that speaks to a relationship, that's the ratio, between different elements or compounds in a chemical formula. We're going to use those relationships in order to create conversion factors. For example, moles of X over moles of Y, or moles of Y over moles of X. And the question is, where are we going to get the numbers from? Well, that's right, the balanced chemical equation. The coefficients from the balanced chemical equation can tell us the ratio of moles to moles for any 2 substances in a chemical reaction. Let's take a look. Let's make some guacamole, okay? Let's look at this equation here. So in order to make some guacamole, let's have 2 avocados plus 1 red onion plus 3 cloves of garlic. And that's going to give me 2 servings of guacamole. It might sound like a recipe, but guess what, folks? Recipes are chemical reactions too. If I asked you to use 4 avocados, how many cloves of garlic would you need? You could probably do that in your head, right? 4 avocados instead of 2, I'm just going to double it, so I'm going to need double the amount of garlic, 6 cloves of garlic. But if you think I'm going to let you get away with doing it in your head, you know me better than that. So let's take a look at some dimensional analysis. 4 avocados, and according to my chemical equation, my recipe, I'm going to need 3 cloves of garlic for every 2 avocados. So my conversion factor is going to be 3 over 2. And that's going to give me 6 cloves of garlic when my avocado unit cancels out. Now, what if I wanted to make 3 servings of guacamole? How many onions would I need? If you answered 1.5, you'd be right, but again, make sure you're practicing your dimensional analysis. If I want 3 servings of guacamole, I'm going to need 1 serving of onion for every 2 servings of guacamole I want to make, and therefore I'm going to need 1.5 onions. So it's all right there, folks, nothing new, just using the coefficients to make ratios so that you can convert from one substance in your chemical formula to a different substance in your chemical formula. The next concept we're going to encounter in this unit is the idea of a limiting reactant. So you should have come up with a definition that says it is the reactant in a chemical reaction or equation which runs out first or limits the amount of product that's going to be formed. Now, to understand limiting reactant, let's make some grilled cheese. Guacamole, grilled cheese, sounds like a party. To make grilled cheese, I'm going to need 2 slices of bread, 3 slices of cheese, and that's going to give me 1 cheese sandwich. So let's ask this question. If I had 10 slices of bread and 21 slices of cheese, how many sandwiches would I be able to make? If you said 5, you'd be right. And I think instinctively you know, I'm going to run out of bread before I run out of cheese. The bread is going to limit the amount of product, the grilled cheese sandwich, that I can make. So the bread is my limiting reactant. Let's take the dimensional analysis that goes into this. If I have 10 slices of bread, according to my equation, I can make 1 sandwich for every 2 slices of bread. That means I can make a total of 5 sandwiches. If I have 21 slices of cheese, according to my equation, I can make 1 sandwich for every 3 slices of cheese, or I can make 7 sandwiches. The problem is I can't make 7 sandwiches because once I've made 5 sandwiches, I'm going to run out of bread. So bread is going to limit my reaction. It's the limiting reactant, and it means I'll only be able to make 5 sandwiches and I'll have some cheese left over. Now, how about percent yield? Well, unfortunately, I've got little kids and they're very distracting, and sometimes you burn things. So I burnt one of my sandwiches. What is my percent yield? Well, remember, percent yield is what you actually got over what you should have gotten, and then times 100% to make it a percent. To make it more scientific, let's say it's your experimental yield divided by your theoretical yield. Again, what you actually got experimentally versus what you should have gotten theoretically, times 100%. Well, if I burnt one of my sandwiches, that means I only got 4 sandwiches. But theoretically, according to my calculations, I should have been able to get 5. So my percent yield is 4 over 5 times 100%, or 80%. Now, what does guacamole and grilled cheese sandwiches have to do with chemistry? Well, everything. If you can do those problems, you can do these problems. The combustion of methane. The reaction of sulfuric acid with barium hydroxide. Or how about the reaction of phosphorus trichloride with chlorine gas? All of these problems are within your reach if you just understand the dimensional analysis we just did. So in the next couple of videos, we'll walk through these problems and see how dimensional analysis takes us from the start to the finish.